Hello, let's move on to lesson 321, evaluating algebraic expressions. By now you have realized that I'm putting my video links at the top of our lesson, and today we are going to be reviewing lesson 321, which is about evaluating algebraic expressions, and there is a little bit of background information for you to read up here, and I'm hoping that you read that before you started working on the assignment. If not, you might want to take a look at it before too long because it will be helpful for you as you're moving through the various parts of this chapter. And what we are going to do first is look at 334. It says the number 6 is represented with plus and negative tiles, positive and negative tiles at right. And this is the negative 6, remembering that these two symbols, and those two symbols all represent 0 pairs, and our 6 is right here. All right, moving on, it says for each problem below, you are being asked to start with a diagram that I provided, show how to remove the appropriate number of tiles to represent the problem given. And then it says in highlighted, you might have to add 0 pairs to have the right amount of positive or negative tiles to remove. This first one says 6 subtract 7. And I've got 1, 2, 3, 4, 5, 6, 7, 8. I've got 9 positive tiles, so I can go ahead and subtract 7 of them. 1, 2, 3, 4, 5, 6, 7. Circle those, draw an arrow because I'm subtracting. And I'm ending up with, I've got this is a pair, this and this make a 0 pair, and I am left with -1, which logically makes sense based on what we know about subtraction. I'm going to highlight the one that is left by itself. The next problem I have is 6 subtract -2. I'm taking a look here, and I've got 2 negatives that I can subtract. And I end up, this is a 0 pair because a positive and a negative make 0. So I'm left with 1, 2, 3, 4, 5, 6, 7, 8. So 6 subtract -2 equals 8. And then the next problem I have is 6 subtract 3. So I'm going to take away 1, 2, 3 at the beginning. Just put an arrow so I know that those go away. And I have these match up, and these match up to cancel each other out. And what I have left is these in the middle. I'm going to highlight them because there's a lot going on right there, and I'll go back and highlight those as well. So my answers in each one of these have been highlighted, and my answer here is 3. Obviously, most of us are like so amazed that we're drawing pictures for some of these easy problems, but it really does help put this understanding of negative and positive subtraction into your brain in a much more solid place. So the next problem, consider the expression 5 plus 4 plus 2 times -3 plus 7 plus -5. Draw the expression using positive and negative tiles. Start with 1, 2, 3, 4, 5. Then I have 1, 2, 3, 4. And then I have 2 groups of -3. So I have 1, 2, 3, 1, 2, 3, 2 groups of -3, plus 7, 1, 2, 3, 4, 5, 6, 7, and then plus -5. 1, 2, 3, 4, 5. Okay. So I've got the expression drawn, and then it says simplify the expression to find the number it represents. What that means is find the answer. Simplify means solve. And I can prove that pretty easily by using these tiles or these symbols. I'm going to match up the 0 pairs, match them up. Just get rid of all these negatives this way. Put that one over there. So what I have left at the end here is all those positive symbols, but let's see what happens when we match them up down here. And one more. All right, so I've got one positive here, and I've got 4 positive there. So proving with my drawing, I've got the answer is 1, 2, 3, 4, 5. Now, if I did this again, the same situation again, only I draw them without the last -5 symbols, I would draw 1, 2, 3, 4, 5, plus 1, 2, 3, 4, plus 2 sets of -3, 1, 2, 3, 1, 2, 3, plus 7, 1, 2, 3, 4, 5, 6, 7. And I match these up so that I am matching up my tiles to give myself a visual of what happens when I'm getting rid of those 0 pairs. And if I do not have the -5 at the end, my answer now becomes 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be 9. Remember, you can pause or rewind or replay these videos as much as you need to. And up at the top, we're back to finishing up analyzing this problem. And when I'm taking a look at this, it says, show how this would change your drawing. We did that up above. And write how much larger or smaller the answer is. So I've got, for letter C, my answer equals 9. For letter B, my answer equals 5. And 9 is greater than 5. The next thing that we included for you to read was the math notes. I'm hoping that you went ahead and read the math notes. This is actually evaluating algebraic expressions. You saw some of these on your last unit formative quiz last Friday. And we have a kid named Jorge, and he was thinking about using variables to represent lengths of a tightrope walker's many tricks. He wrote the expression x plus x plus x plus x plus 3 to represent the sequence shown at right. Does this make sense? Well, we could say yes, because we know that Jorge moves 4 times, 4 x's, and then a 3. We don't know his distance yet, but the x's are all the same size. So that's one way that we can identify or kind of analyze what's going on up here. Down in letter B, it says write an expression to represent the sequence shown in the diagram at right. We could write j plus k plus k plus k, or 2j plus 3k. If k equals 5 feet, how long is the tightrope in part A? So that would be 5 plus 5 plus 5 plus 5 plus 3, or 4 times 5 plus 3 equals 23. In part B, if j equals 3 feet and k equals 2 feet, how long is the tightrope? For this one, we would rewrite 3 plus 3 plus 2 plus 2 plus 2, or we could write 2 times 3 plus 3 times 2, and that would give us 6 plus 6, which would give us 12.